Testing, testing. Great.
Yeah, I think if you want to, if there's that large scale, then you might want to use large language models like GPT-4 from your app. Yeah, that'll be a good starting point. But you probably need to have the resources to do that. If you use like a really small data set or like a very poorly annotated data set, then you're going to get garbage pretty much.
Okay. Wait, is this next one just Docker?
Yep.
Yeah.
Is it, what time is it?
It's supposed to be starting 5 minutes ago.
What time is it?
8.
Is there another one afterwards?
Nope, just that one. Sorry, I'm still trying to set this up, so. Why is it scaling weird?
I use my Hangouts, so I have my K whatever. Nobody's going to steal it.
Yep. Also, please make sure to sign up on the notebook, or sign in on the notebook over there if you have not already. Why can I not get this to capture method, capture cursor? There we go. I don't know what I changed, but looks better. All right. There we go. Okay. And do make sure, if you're not on our Discord, I strongly recommend joining our Discord. I'm going to share a link to the presentation slides on Discord right now. Let's see. And then okay, looking good. All right, pretty much all set. Just give folks a minute to get settled.
It's asking for Wi-Fi.
Wi-Fi.
Oh, I get
Yeah.
yes, Wi-Fi.
All right. And I know we don't really have power outlets here. If you do need power, there's a power strip over here. You may want to move over here if you think you'll need it. I apologize, we don't have a lot of outlets in this room. I just give folks another moment to get settled. Also, if you don't have Docker desktop installed, please do so now. All right. I'll just take a quick peek outside to see if there's anyone lost for a moment.
It was good. My voice is about to break because like I'm a little bit sick, so like my voice was going out. Thank you. So, thanks a lot.
All right. So apologies for the extreme delay. Let me go ahead and remove this message. Where is it? There we go. Okay. So, hello everyone and welcome. For those of you joining us for the first time, this is Code Soul. We do IT education in the greater Seoul area. I'm Beege. Been doing software stuff for like 11 years, and today we're going to present on Intro to Docker. I do recommend joining our Discord if you have not already. That's where you can ask questions, share information, or just kind of hang out with people. You can scan this QR code with your phone right now if you want to, or you can just enter that link in a browser. I did share the slides and a link to the YouTube stream if you want to check that out. Speaking of, audio looks good. So let's go on ahead. So, disclaimer, I put this in front of all my presentations. I'm not a super expert in this stuff. I'm just sharing what I know and the stuff necessary for me to get my job done. This is not meant to be a comprehensive lesson. And always check stuff to make sure it works. Always test things, just like you shouldn't just blindly copy and paste Stack Overflow answers, right? So today, we're going to go over what exactly is the problem that Docker was built to solve. We're going to go over what is Docker, what is a Docker container, which is one part of Docker, what are Docker images, which is another part of Docker. We're going to actually help you run a container yourself. Again, please make sure you have Docker Desktop installed if you haven't already. We'll create our own Docker image together, and then we're going to run multiple containers together. Any questions about the agenda before we get started? Cool. We are starting quite late, so I might rush a little bit, but if you do not understand something, please flail at me and tell me to stop, okay? If you guys do not understand this, then we're just wasting time. So I don't like wasting time. Let me know if you don't understand something. I'm happy to answer questions. Please interrupt me. I don't mind being interrupted. Please go for it. And if anyone is watching on stream, I'm trying to get better about watching the chat. I have it on my screen right next to my presentation notes, so it should be okay. All right, so no questions about the agenda? Good? All right, let's dive in. So what is the problem that Docker is meant to solve? Back in ye olden days, software engineers would write software on their computer, and they'd test it on their computer, and then they'd package it up and send it off to be installed on someone else's computer. And then it wouldn't work. And the business would be like, engineer, your code doesn't work. What's the problem? And the engineer would say, well, it works on my machine. And the business would say, your machine is not the customer's machine. Do you want us to give the customer your machine? And this meme is perfect. So the reason that those kinds of problems happened is that setting up an environment for software to run can be hard sometimes, right? Each software requires all sorts of different stuff to run the way it needs to. Along with that, different environments are very rarely the same. You're not going to have the same exact versions of all the same exact softwares installed on two computers, right? It's also difficult to share environments, right? Since these environments are different, but maybe your software requires a very specific environment, how do you make these two things the same? If you have a way to share the environment, that makes it easier. And then virtual machines were built to solve this problem. If you're not familiar with what a virtual machine is, if you've ever used a Mac and you've run Parallels with Windows on your Mac, you're running a computer, a whole Windows computer inside your Mac computer, right? That is a virtual machine. You're basically running a computer inside your computer. And virtual machines were meant to solve exactly this kind of problem, but virtual machines are very large, they're difficult to set up, they're difficult to share, and so people were looking for better solutions. Enter Docker. Docker allows you to define your environment as code, right? So, you can define all the different software versions installed, all the file system configurations, all the ports and all that kind of stuff, just as code like you would any other software. Docker environments are isolated, right? So if you have multiple Docker containers running, they don't interfere with each other. They have their own space, almost like a virtual machine, and they're portable. You can share Docker images, right? So if I make a new Docker image on this computer, I can send it to your computer with very minimal effort. And then if you start running it on your computer, we have the same exact environment. No problems. Docker is composed of two key parts. Now, I am very much simplifying. I am super oversimplifying here. But you can think of Docker as images and containers. The way I usually explain what these mean to people, an image defines what the environment should look like, and the container is the environment actually running. A metaphor could be the image is like a blueprint saying this is how the building should be constructed, right? And then the container is the building constructed from that blueprint, okay? So you can make many buildings from the one image, and all those buildings will be exactly the same, because they're all from the same blueprint. So if you make a bunch of containers from the same image, each of those containers will be the same. based on that image. Okay? Now, the words images and containers may be a little bit confusing right now. I'm going to explain why they're called that in a little bit. Another thing is that it's shareable, right? So if I make a Docker image on my computer, I can send it to your computer very easily. I mentioned that already. And honestly, it's just how we do things. Well, 2023 now. This presentation's a little bit old. But Docker is very common. If you're an engineer in the modern day, you're usually expected to know Docker, unless you're doing something like embedded systems or games or something like that. But if you're doing anything on the back end or sometimes even front end, you're usually expected to know Docker. If you're doing DevOps, you must know Docker. Okay. Any questions about what we've gone over so far? Yeah.
So can I think of images as something like a set of instructions to build environments, and think of containers as something like the environments is an instance of environment?
Yeah. So the question online was, or for the people online and for the recording, the question was, can I think of an image as like a set of instructions on how to set up the environment, and then a container is in like the environment after all that setup has been done? That is not how it works, but that is how it functions, right? Or wow, that from a user perspective, it can seem like that. Internally, it works differently, but for your usage, yeah, I think that's pretty reasonable. Does that answer your question? Cool. Other question? Yeah.
The environment as code. What is the difference between the infrastructure as a code, like Terraform?
So the question was, what is the difference between an environment as code, like Docker, and infrastructure as code, like Terraform? So environment is a bit of a difficult word. It has many meanings, because an environment can also talk about an infrastructure environment, right? In this case, we're talking about a file system, environment variables, ports, and kind of the main running process. There's a little more to it than that, but those are the key things. That's what Docker mostly covers. Terraform covers a more broad range of things. Terraform covers how many servers do you have running, what are the network configurations, what are the access control permissions, what are all sorts of managed services. Terraform is much broader. We're not going to go over Terraform today. I think I have a Terraform presentation somewhere. I'll have to check. If not, I could totally do one. But at the end of the event, I'll share a link for you to see all of our presentations, and you can find the Terraform one there. Does that answer your question?
Yes, I think so.
Cool. What's up?
Can you run Windows on Docker?
So the question was, can you run Windows on Docker? I want to say no, but I've heard of some weird things, but I never bothered looking into it. Docker runs using Linux C groups, which Windows does not have. And when you run Docker on Windows, what Windows actually does is create a virtual machine and then runs Docker in that Linux virtual machine. I'm quite confident that there's not a way to run Windows in a Docker container, but I've heard of some weird thing about that. So I'll give you like a 80 to 90% no, but I'll look in to give you a more confident answer later. Is that okay?
And also, like, for example, if my virtual environment in Docker should have some drivers, so is there any way to give instructions to install specific drivers to some specific hardware? How do you manage that?
So the question was, if your software requires specific drivers, how do you manage that? So I know the use case you're talking about. We actually do the same thing at the company I work at. So if in this case, you're usually talking about something like machine learning, and you're usually talking about like GPU drivers, right? You can do that, yes. You can install like the NVIDIA CUDA drivers for inside a Docker container, and that will work as long as the host machine has the proper hardware, and you might have to do a little bit of configuration on the container side. I don't exactly remember. I'll have to look into it more, but it is possible, yes. Does that answer your question? Cool. If you want to go more into like actually running a container like that, we can talk about it, but it's outside the scope of this presentation. And then you had one?
Never mind.
You're good? All right, any other questions before we continue? All right, I'm ditching the jacket because it's kind of warm in here. Okay. Ugh. Okay. Good enough. All right. So, what are containers? Right? We keep mentioning containers. In a literal sense, a container is a C group in Linux. A C group is kind of an isolated environment where you have one running process as the main process. Okay? And that environment has its own environment variables, its own process management, its own file handles, its own file system, its own ports, its own network. It's like a tiny computer. But it is not a tiny computer. It is not a virtual machine. The reason that this stuff only works in Linux is because C groups are built for Linux, and Linux supports creating these isolated environments without creating a whole operating system. Okay? So the whole Linux kernel does not exist. You know what? I'm not sure that's 100% correct. In any case, a lot of the overhead that would be involved in running a virtual machine is not used in Docker containers. So Docker containers are much easier to share. They are tiny and fast. Okay? Some Docker images can only be like 200 megs, which is quite small. And they even have Linux distributions specifically made for Docker to minimize the size to make it easy to share. And it operates like a tiny computer inside your computer. So if you're like, okay, that makes sense logically, but maybe I need to visualize it. Unfortunately, there isn't really a way to visualize it. This command line output is the closest thing. If you do Docker PS, which is a command that lists your running Docker your running Docker containers, this is what a container looks like when you see that. So you can see that when you run a container, it generates a container ID, which is just a random set of numbers and letters to identify that container. It tells you what image the container was made from, which blueprint that container was made from. It lets you know what the main process command is that's running. And then it tells you, how long ago it was created, how long it's been up, or if it's not up, what ports are available if necessary, and the name of the container. You can give name to the containers to make them easier to track. If you do not give them a name, it will automatically generate a name, which is kind of nice. So any other questions about containers so far? I know it might be a bit nebulous. Yeah.
It might be trivial, but can a machine run multiple C groups at the same time?
Yes. So the question was, can a computer run multiple C groups at the same time? Yes, absolutely. That is one of the main use cases of Docker. How much time do we have? Yeah, let's go into it. So these days you have a lot of different runtime environments. You have Python, you have Node.js, you have Ruby, all these different things. And these all are kind of single-threaded, right? They run on one CPU core. But these days, the average CPU has 4, 6, 8, 16 cores, right? So one of the reasons things have kind of gone this way is often you want to maximize the use of one of your cores, right? You want to make as much use of all your different CPU cores as you can to get out the most. You basically want to make the most efficient use of the CPU you paid for by using as many cores as you can. So if you have a Node.js app, all right, and you put it in a Docker container, you can assign multiple cores to a Docker container, but by default it's usually one. And so what you can do is you can spin up many Docker containers, all with these single-threaded processes. Each of them can grab their own CPU. And then you can maximize use of each of those individual CPUs. And if any one of them fails, You don't care. You have like 10 more, right? So that's another big thing about Docker, which I should probably add to this. Because they're so light and fast and easy to set up and tear down, we've ended up building these kind of self-healing applications where if any container fails or crashes for some reason, we don't really care. If it crashes, you just kill it, you make a new one. They're meant to be ephemeral. They're meant to be transient. They're very easy to set up. They're very easy to tear down. So spin up a whole bunch of them, and if any of them fail, just throw them out and set up a new one. And that's also why on the back-end side of things, and back-end server development, back-end web development, everything is stateless, right? Because you don't want to maintain state in one of these containers if the container can just disappear. Right, so in this way, we have a lot of interesting self-healing infrastructure built around Docker. So that's way more than you asked, but does it answer your question? Cool. Other questions? Also, quick note, if I'm speaking too quickly, if it is difficult to understand me, please tell me to slow down a bit. I get excited about this stuff, so you could just be like, Beege, like slow down, and I will slow down my pace. I just find this stuff fun, so feel free to tell me to calm down. Okay?
I have a question.
Yes.
So you say that if container is unempty,
Mm.
you can just share.
Mm.
But if someone wants to automate it, like some management service,
Mm.
so that does it need some kind of some APMs or logs
Mm.
to check the health and share and make other containers?
Mm. So the question was, let's say you're running containers on some cloud service. Do you need some kind of application performance management, or application performance monitoring, some kind of monitoring system to watch the container, know that it's in a bad state, and then kill it and bring it back up? Yes and no. So generally, that's a good idea. You want that. And most container orchestration systems, like Amazon Elastic Container Service, or Google App Engine, or if you want to be super fancy, Kubernetes, you can just tell them, hey, run this like usually single line command to check the health of the container. If that command fails, kill the container, make a new one. So often in the context of web servers, you'll make some kind of health check endpoint, which just, the server receives a request and spits out a response. And people usually use that to check the health of the container to see if it's properly running. And so the orchestration system will just make a request at that endpoint every 5, 10, even 1 seconds. And as long as it returns okay, container it doesn't care, everything's okay. But if it fails, and you can configure like how you want to check how many times it fails and all this kind of stuff, the system can kill it, make a new one. So there is some very, very basic monitoring built into container orchestration systems, but you can put additional monitoring on top of that and have the two systems talk to each other. So there's a basic built-in version, and you can go more advanced if you want. Does that answer your question? Cool. So does that make sense to everyone else too? Cool. Any other questions? Great. All right, moving forward. So, yeah, this is me right now. So we talked about containers, right? The buildings. Now let's talk about the images, the blueprints, right? I keep saying these portable environments, right? I should reorder these actually. Let's start with the bottom bullet point first. So why is it called an image, right? Like, an environment is not a picture. I mean, I guess you could kind of argue that, but the etymology comes from ye olden days, right? Everything used to be like CD-ROMs, right? Does anyone remember CDs? We don't really use them anymore. And a CD, it's read with a laser, right? So the laser sends some light out, the light bounces off, it looks at what the light sees, and then that means some kind of data, right? That's actually how our eyes work, right? Light comes from some light source, it bounces off of you and enters my eye, right? And so I interpret that as some kind of image. Like a CD. A CD is an image. CDs are actually called optical storage because optical just means light, looking at things with light, okay? So CDs, the data on a CD is called an image, okay? Same with hard drives. We say there's a disk image, right? Because it's all based from the old days of optical storage, which we don't use as much anymore. When we transitioned to virtual machines, we maintained that nomenclature, that name of images, okay? And when we went from virtual machines to Docker, right, even though it's all virtualized and there's no optics anymore, we just maintained the word images, okay? So that's where image comes from. An image just means the data from some read-only thing, like a CD, used to set up other stuff, okay? So that's why we call it images. I explain that because when a word's known meaning doesn't match its used meaning, that takes up thinking power for you. But once you kind of can build this bridge, you can think about it faster. So that's why I explain it. So what is in an image? An image is basically a software package. Okay, like I said, it's kind of a set of read-only data. And it contains code that you could put in the image when you are constructing the image for the first time. It contains a runtime. So maybe if you're doing like Java, you could have the Java runtime environment in there. Or if you're doing Python, you could have the Python interpreter in there. Or if you're doing JavaScript things, you could have Node.js or some other V8 engine, whatever. It also might have some tools. Maybe you can install some utilities in there. And it has files. It has a file system. Okay, so this is what an image is. It's all these things compacted into some kind of read-only storage that acts as a blueprint that you can make containers from. Okay, so hopefully everything's connected now in your heads. Does that make sense? Any questions about this part? No way. All right, cool. If you have if questions pop up, interrupt me, please. All right, so cool. So I know what an image is. It's this environment thing which has like files and code and runtime and all that. How do I get one? Well, you can get them from the internet, like most software. Specifically, there's a website called Docker Hub. You can go search for that if you want. They have a whole big giant list of images. That said, the Docker Foundation, I think it's called, basically the company or organization behind Docker, has been changing their usage policies and their payment policies lately. So a lot of people are moving off of it because they don't like how Docker has decided to do things. So Docker Hub is still the biggest one, or the biggest place where images are stored. We actually call a place where images are stored a registry. So it's the biggest registry. But there are other registries, like GitHub has its own registry. You can actually create your own registry and put Docker images on that. Many companies do that. So you can get an image from a registry, or you can build your own, which then you probably want to put in some registry somewhere anyway so you can share it. Okay, does that make sense? Cool. So how do you run a container? Right? First you choose some image, basically what environment do you want to run. There's a command if you've installed Docker Desktop called Docker, and that Docker command has a subcommand called run. So you do Docker run, some stuff happens, and then you have a container. So go ahead and try it. Go ahead and open up either command prompt if you're on Windows or terminal if you're on Mac, and type in this Docker run hello-world. Now I'm going to do it here too. Get big. There we go. Okay. Please disregard my old usernames. Okay, now you don't have to see that. So I'm going to do Docker run hello-world. Okay. So everyone please type this on your computer. And then run it. Wait, do I have Docker Desktop running? Yes, I have it running. Okay. And, oh, did I clean my cache? I did not clean my cache. Anyway, give me a second, actually. Please pardon this for a moment. Okay. Now it should look like, nope, oh well. So when you do Docker run hello world, what you should see is it should say something like, image not found on this computer. It's going to go pull the image from the library, and then you'll see it'll do some downloading, it'll do some unpacking, and then it will print this. So if you have gotten to this point and you see this output on your screen, congratulations, you've run your first Docker container. If you don't see this, please wave at me so I can help you fix stuff.
The side comment, but can you try Docker -f hello world and then rerun it?
So that prune should have done that.
Drop it in this way.
Oh, interesting.
So can we try Docker -f hello world?
Cool, thank you, Jay. Okay, there we go. So unable to find image locally, then it's going to pull the latest version from the registry. It gives you some information like, hey, we downloaded it, and then you see the output. Cool, thank you, Jay. Has anyone not gotten this far? You need help? All right, give it just a second. Docker daemon is not running. Cool. Okay. So, if you get a message like the Docker daemon is not running, what that means is you either don't have Docker Desktop installed, or you do have it installed, but it's not running. Actually, no. Sorry. If you get the message that the Docker server is not running, that means you do have it installed, but it's not running. So what you want to do is if you're on Windows, you hit the Windows key, you type in Docker Desktop, you hit Enter. And then you give it a moment to kind of figure itself out until you see the little green bit down here. So go ahead and start Docker Desktop on your notebook. And then once you got this little thing down here turns green, then you can go ahead and run Docker run hello world again, and you should be good. Put this on the screen for your benefit. All right, so give a minute for people to catch up. While people are catching up, does anyone else have other questions? So, good question. So, San asked, what just happened when we did this? So, as mentioned, it went online. It saw that this image was not on this computer. So, it went and pulled it from the internet. Okay, so, it had some updating progress stuff. And then once that was done, it lets us know. Now, the Hello World container just has a tiny little program inside it that prints out this message. So what happened was, when we said run hello world is the name of an image. Okay? It goes, downloads that image, and remember, an image is like a blueprint. So from that image, it creates a container. And then it runs that container. And that's what we did here. And the container, all the container did was print out this message. So let's do something a little crazy. Oh, hello, caps lock. Oh, is it BusyBox? Oh. Nope. Which one? I don't think it's going to have bash. Yeah. Nope, okay. I was going to try to get into the container and show you the script that it was running, but I don't know how this container was built. And I don't remember how to inspect the file system and all that. But basically, there should be some script in there that just runs this. So yeah. Does that answer your question? Mm-hmm. Cool. Other questions? Oh, what's the Wi-Fi password? That's important. Let me just help you out here. I don't want to put that online. Yeah, I got it. And let me know if it works.
It says I need a
Oh, you gotta update. So yeah, basically click that link and follow the instructions. Yeah. Okay. Yes. What you got? Yes, I did. I did try run. So that's for a container that's already running. I tried it when starting a new container, but it's the same idea. But thank you. Yeah. The problem is that there's no batch. Yeah. But thank you for checking. What's up?
I think it might not be running because after the script runs, the container kills itself. Or it closes up because.
Right, but when you do batch.
I mean, you can't log in if it's not running.
Right. So what happens is when you try to do something like this, instead of running the main command that's configured in the container, you say, hey, I want to run this command instead. And so what was happening was it was saying that it can't find this command to run. So basically, I was saying rather than run your normal command, run this command instead. And it's like, I don't know what that command is. It doesn't exist in this file system. But yeah, thank you for checking. No such file or directory. And I tried all the shells I know of that it could possibly be, and
I don't think it has any shells like this.
yeah, I don't think they put a shell in it. What's up?
You can try Docker exec.
Docker exec is only for containers that are already running. And so this is it just runs the one command and then exits. There's no chance to like force it to continue running.
But with run, you can run it in the container even though it's not.
Yeah, so run will start the container with whatever command you tell it to, or the default command if you don't give it a command. Yeah, so if we do like docker run --help, you can see the usage here. You give it an image and then an optional command, and then arguments to the command. So in this case, I was telling it run the command busybox or bash or just sh, and none of those worked. So I don't think it has a shell installed in it. It's meant to be the smallest possible image, so they probably just didn't even put a shell in the image. But thank you for checking. All right, any other questions before we move forward? All right. So we're at about halftime. I think we're doing okay. So let's, I can't see the taskbar here. There we go. Okay. So we can do another thing. So that ran a nice little hello world program. But let's do something a little more interesting. Let's try running a web server with Docker. Okay, there is a web server called Nginx, Nginx. And Nginx is a very commonly used web server, and it works without any configuration. So we can try running the Nginx Docker image as a container, set up the right port for it to run on, and then we can actually just run a web server on our computer with just one command. So go ahead and type this one here, and then try visiting this web address. Go ahead and try that. I'll give you guys a little bit of a head start, and then I'll follow along too. And I'll explain what the -p 8000 part is in a minute. But for now, just try running this. Now you guys have probably got enough of a head start, so let me try to follow along. Let me just do this so that you guys can still see it. And for benefit of the stream, there we go. So docker run -p 8080 nginx. Okay, so you're going to see a whole bunch of output like this, and then you're going to lose your prompt, right? But that's okay. You go to a browser. So let me just go in here. What? No, don't tell me that now. All right, give me a second here. Oh, no, that's weird. Give me just a second. Kicked me out, and I don't want to share certain stuff all over the internet. Please allow me a moment. Okay. There we go. That was weird. Okay. But if so I've got Nginx running here, right? Whoa. Sorry, running here. And then I can do http://localhost:8000. And there you go. That is the Nginx web server running on your computer with just one line. Because the Docker image already has an Nginx installed, already has it configured, and already sets it running on port 80. Now, you might be wondering, what the hell is port 80? Beege, you keep mentioning this word port. I don't know what a port is. If so, welcome. You're going to be learning a whole bunch more stuff like this. Actually, before I go into that, who doesn't know what a port is? Please raise your hand. Everyone knows what a port is? Okay, cool. Then I'm not going to waste time. Thank you, OnLab. You are so helpful. Okay, then I'll skip the port, or skip explaining what a port is. But anyway, when we ran, and to kind of kill the server, what you can do is you can do a Control-C in your terminal, and that'll kill the web server. And you'll see if I go here, it's gone, it's trying to hit it, and there's nothing there because we killed the server. So going back to this command here, this -p 8000:80, I mentioned that a C group also had its own ports, right? When you set up a Docker container, it has its own little private network inside your computer. It's like a mini internet in your computer. And so each container has its own IP address and has its own ports. But the container's ports are not your host computer's ports. They're not this machine's ports. They're virtual ports in the virtual computer. Or not a virtual computer, because it's not in a C group. So if you want to access port 80 on your Docker container, how do you do that? Well, this is how you do it. This -p, you can also do --port, it means the same thing. But it says, hey, Docker, go ahead and take port 8000 on this computer here and direct it to port 80 on the container. And we create a bridge between the host machine's network and the Docker container's network. And that way we can access that port 80 on the container using port 8000 on our host machine. Why do we use port 8000? Because usually ports 1000 and below are reserved by the system, so we just have to pick a bigger port. Does that make sense? Cool. Any questions about running the Nginx web server via Docker? Pretty good. All right. So let's continue on. Yeah. Control-C on your computer. Yep. Just in general, Control-C is like your oh shit button. It will send an interrupt signal to whatever the current process is in your terminal. So if you accidentally write an infinite loop or something, you can try to Control-C to kill it. Not always guaranteed to work, but most of the time it does. All right, so getting back into it here. I can't see. Yeah. Okay. Or I could have just turned around. That probably would have been easier, but whatever. Okay, going through the things. All right, so when we ran this container, I explained to San, like, oh, we downloaded an image and we ran a container, but like, is that real? No, of course not. I'm simplifying things. This is a little more detail. So how does Docker itself work? When we're typing on the command line, Docker run whatever, right? That's actually not Docker itself. That's just a command line utility, a tiny little tool that calls out to Docker to tell it to do stuff. Docker is a server running on your computer. Now that server may or may not be exposed outside of your computer. I think by default it actually uses a file as a network socket so that the rest of the internet can't reach your Docker server. But you can configure it to run on a port so that it's accessible from the outside. But your Docker client, your Docker CLI command, just makes a request to the Docker server, and then the Docker server does all the work. So that's why earlier when we hit the message of like, hey, your Docker's not running, right? That's because the Docker server was not running. So when the command line utility tried to tell the Docker server to set up a container, it's like, there's no server there. I can't tell it to set up the container because it's not there. Now that server is a daemon. A daemon is just a process that runs in the background. A server is a process that runs in the background that fulfills requests, that serves, right? So the daemon, the server, is the part that actually runs the containers, stores and manages the images, pulls the images when necessary, all this kind of stuff. And then there's another part as well, the registry. Where did we pull the image from? We pulled it from a registry out there on the internet. Okay, so this is the more detailed architecture. Why do you need to know this? Well, in cases where, for example, Docker says, hey, the server's, I can't connect to the server, now you know what that means. Because otherwise you'd be like, wait, what Docker server? There's a server? Yes, there is a server. Okay? Does that make sense to everyone? Cool. All right. Where is my mouse? Okay. So, cool. We've run containers, right? But what if I want to make my own image? Well, we make something called a Dockerfile. I should have fixed this slide. Actually, no, this is fine. So, I've already written a Dockerfile for you. Okay, just to save time, because in the past when we ran this and we had people write their own Dockerfiles, I spent like 45 minutes running around and helping people fix typos. So we're not doing that anymore. Go to this page. This is a repository that I've already made. And you can clone this down. Okay. I'll give everyone a minute. If you don't have Git installed, you can download a zip file and just unpack that. But I think most people in here will have Git installed already. If you on the internet don't have Git installed and you're like, what the hell is Git? What do I do? Join our Discord and ask us and we can help you. Or you can Google it, but it's nicer to have someone walk you through stuff when you run into the inevitable problems. So go ahead and go to this page and clone down the project. And if you're not sure how to do that, I'm going to walk through it in just a moment. But I anticipate that I'm going to run through it faster than people doing it solo, so I'll just give them a bit of a head start. Now, if you don't want to clone down the project, you can just make a Dockerfile yourself, but you want to make a directory for it and then put it in. Alternatively, if you guys don't want to type in this web address, and you're on the Discord, you can just go to the presentation and go to slide, whatever slide this is, and just click the link. That's probably easier. And that's what I'm going to do now. Whee! Okay. So here's the repository. I actually made a blog post about this same topic, so if you want to refresh stuff in text form, you can just go check the blog post down here. It's basically just the README. And it's there's an English version and there's a Korean version, if you are so inclined. I did not write that. My Korean is not that good. But we're going to clone this down real quick. And I'm going to go to I'm going to remove the folder because I have it cloned already. So I'm going to do git clone, paste. Nope, this is Windows. So I'm going to clone it down. All right, and then I'm going to go into that cloned directory. So I'm going to do cd blog docker. And then you'll see here there's a whole bunch of directories. We want to go into the server directory. Okay. And then you'll see this Dockerfile here. So let me take a look at this Dockerfile for you. Okay. How did I do this? Give me just a second. It's been really? Okay. Okay. So before we run this, I'm going to explain what the hell's going on here. And I'm going to add more slides to the presentation later. So this is a Dockerfile. This is how we define a Docker image. Okay? The Dockerfile is used to create the image. You almost never, like 99.999% of the time, you're never going to make an image completely from scratch. There's no reason to. There's no good reason to unless you're doing some really crazy stuff. But if that was the case, you wouldn't be here. most of the time you're going to base your image on top of some other image. You're going to take an existing image and you're just going to add stuff to it to do what you need, because that's how pretty much all of software works. We're not building compilers from scratch and assembly code and all that stuff that I learned from a Minecraft video recently. So this from directive tells Docker which Docker image we're going to use as the foundation to build our Docker image on top of. Okay? So Alpine is just some Docker image out there. It's a minimalist version of Linux specifically built for Docker. Okay? So we're basing this on the Alpine Docker image. And then the run directive says, hey, run this command line directive, right? So it's just like as if you were to type in your terminal, okay? So for Alpine, Alpine has APK, which is Alpine Package Manager. Excuse me. Alpine Package Manager is just used to install stuff. So if you're familiar with Ubuntu, it's like apt. If you're on a Mac, it's like the App Store. If you're on Windows, it's like the Microsoft Store, okay? So you can say, hey, Alpine Package, whatever K is, I forgot already. Yeah, I don't remember. Okay, anyway, the Alpine Package Manager, add this software, and we don't want to, I just added the no cache flag because otherwise it'll like cache a bunch of stuff and make the storage larger, and we don't need it. We're installing one thing and we don't care. And then there's this ncat command, and we want the nmap flavor. Don't worry too much about that. That's outside the scope. It's a networky thing. And then we're adding dot is the current directory, and then like slash is just saying, the stuff inside this directory. So we're adding everything in the current directory into the current directory in the image. Okay? So the image has its own file system, and we're just copying the stuff from our folder into a folder on that file system. Then we say, hey, we want to expose port 8000. We want the application to be able to talk on port 8000. And then we say, if we just run a container from the image directly without any additional configuration, run this command, which is a shell script that I wrote. Okay? So from means base this image on some other image. Run means, run these command line commands. Add means copy files. And then expose means, allow this port to be used. And command says, hey, when it starts, run this. Okay? All good on that? Cool. So now you might be thinking like, okay, so you install some software that I don't know what the hell that is. You're adding some files that I don't know what the hell those are. And then you're running some script, which I don't know what that is. Let's explain that briefly. So this script is the tiniest web server I could come up with. ncat is network concatenate. It's basically just a very tiny network utility to just send data across the network. Trap is basically determining signals. So basically, if you try to kill the server, it kills it properly. And then while true just means it repeats. So this ncat script listens on the current host, basically the current computer. And it listens on port 8000. And it serves the contents of hello.http. And then the ampersand at the end says running it in the background. Okay? So maybe I didn't need... Oh, yes, I did. So what is that hello.http? It is the almost smallest possible valid HTML page. Okay? So this was like the smallest server I could come up with in a couple hours. Okay? So it's a tiny, tiny web server, but it's not just some magical Nginx stuff. We made this ourselves. Okay? So when we do this Dockerfile, right, we install ncat because we want to use that in our script. So that's setting up the environment, right, setting up the file system, adding the utilities we need for our software to run. Then we copy our code into the image. We say, hey, we're going to use this port, and then we run our program. Okay? This is a normal workflow for a Dockerfile. Most Dockerfiles will look something like this. More complicated because they'll do a whole bunch more steps, but the general idea is the same. Does everyone understand so far? Cool. So, let's go ahead and, if you've cloned this down, I do not have enough screen real estate. Okay, if you've cloned this down, go ahead and do docker build. What's going on here? Oh, it's off the screen. Hey, look at that. Okay. Yeah, come on. Yeah. What? Okay. Do docker build, and I need to fix this for the stream. Okay, there we go. Docker build dot dash t intro server. Okay, so build will build an image from a Dockerfile. Okay. Dot, as usual, means the current directory. Why the current directory? Because when Docker builds an image, it needs to know where are the files that you want me to use to build the image. Additionally, Docker expects there to be a file named Dockerfile with a capital D. Okay? If there's no file with a Dockerfile name, capital D, if that file doesn't exist in that directory, it's going to go like, what are you doing? I need a Dockerfile to build an image. Okay? And then -t is a tag. Basically, you can give it a name. Okay? So we're building an image from the current directory, and we're giving it the name intro server. Make sense? All right, let's do it. I missed. So you're gonna, damn, that was fast. So 2 seconds, that's quite good. So what, you can go ahead and run that on your computer too. What that's gonna do is it's gonna download the Alpine image, because that's what we based our image on, and we need the image to actually do work with. So it's gonna download the Alpine image, and then it's gonna run our command, and then it's gonna copy the files, and then it's gonna, do all the stuff that we told it to do in the Dockerfile. Okay? Is everyone able to run that? Good? Good. All right. We're doing great on time. Okay. So now we can do docker image ls, ls being short for list. And I have way too many images. But somewhere in here, do you think I use Docker? There we go, intro server. Okay, you should see an intro server image. Okay, because that's the tag we gave to it. Right? So now, you want to run that server, right? Is everyone okay? Do you guys have questions, or do you have trouble? Okay, they're figuring it out. So now, let's go ahead and try running a Docker container from this image. So we can do docker run intro-server. I forget if we still need to tell it to expose the port. Let's just try it. And if it doesn't work, we'll tell it to expose the port. So I'm running intro server. Now nothing's going to show up. Remember when we ran Nginx, it showed all that logging output being like, hey, I'm doing stuff. Our server's not that fancy, okay? So if you just hit enter and then nothing happens, you're good. Don't panic. Then go to your browser and go again to localhost :8000. What? I'm sorry, what? Okay, no, sorry guys, I made a mistake. Control C, docker run -p 8000 :8000 intro server. There we go. Ooh, lovely. This is what you want here. And then if you visit localhost :8000 in your browser, you should see this hello world stuff. Is everyone able to get that far? Good? If anyone's having problems, call out to me. I'm here to help. I also need to fix my posture and relax a little bit. So let me just let me clear this out real quick. That's what it looks like. Okay. Does anyone need help? Yeah, I got you.
This container
All right, so if you're on Windows and you're having trouble, I know what the problem is. I don't yet know the solution. If you're on Windows, what's happening is when it copies the server.sh script into the container, it's using Windows line endings. And the shell inside the Linux container does not understand Windows line endings. So it's just exploding. Give me a moment. Give me a moment here. We'll figure this out given a moment. I want to make sure it's not a problem with the repository before I do some other kind of solution. And then, what? Oh, right. Yep, sure enough. Okay, so CRLF. All right, give me a moment. No, I don't want to do that. Are you kidding me? No.
What was the error?
No. Huh?
What was the error?
The server script is using Windows line endings. Yeah.
Isn't it like in the Dockerfile, just the format should be server message, Linux style or Windows style?
So it's it can actually find the file just fine. It's just confused about what it is. It doesn't recognize it as like an actual shell script. Give me a moment. Does cat work? No.
That's what you meant. Or like using a function in general, not like Docker itself. Right? Yes, guys.
Okay. Okay, well, give me just a moment. I'm going to try something. Sorry, folks. I ask for your patience while I try to fix this issue. I have some idea of how to fix it, but we'll see. No, I just want that one file. That's weird. Oh, it's the line ending nonsense. Okay. It's weird that I haven't had this problem in the past. Really? Well, I'm glad we're really good on time. So, for the future, when we run this event, we're going to tell everyone to use Windows Subsystem for Linux because this is dumb. In the future, if you're doing Docker things, don't use Windows directly. Use the Windows Subsystem for Linux because Windows is trash. And I'm totally fine with broadcasting that all over the place. So did it work? Okay. Now, yeah, I'm not a fan. Not a fan. Only reason I'm using it is because video games.
I think that's why most developers never use Windows is for developers video games.
Yep. Alright, sorry folks, we're getting there. Nope. Oh. What the hell is going on? Okay, cool. Let's try this again. Let's do this one because I'm on Windows. Actually, I think I have Windows configured to work for this. Let's try it. I just deleted it. Okay, fine. Goodbye. Try again. Why? Why is it not already installed? Why is it? Man, really? Hold up. No. Stop converting it.
Did you see that thing that said change line icons?
Yeah. Oh. Oh. Oh? Alright, hold up. Let me... Sorry, folks. Give me a minute here. What? Why? Alright, I'm going to ask you to do a git pull on that in a minute. Because everything is jacked up. Okay. Why are the images changed? That doesn't make any kind of sense.
If you go to the Git thing on the left side, you can highlight everything and then right click.
Well, no. I don't
Start
want.
changes.
I don't want to.
And you can discard changes
I don't want to discard changes.
for the images.
Yeah. Okay. All right. right. So now let's try. What? What? Oh.
Oh, yes.
Okay. This is Windows. Okay.
Yay.
Wait. We're not out of the woods yet. Okay, now we're out of the woods. Okay, so I apologize for all the trouble and confusion. This is why you don't try to code at like 1 a.m. Please do a git pull and try building again. The issue was that I was not having good discipline about doing this in Windows versus doing this in Linux. And so some files had Windows line endings and some files had Linux line endings. So because there was a mix and match of things, the Git didn't properly convert everything. So when Docker copied the files into the image, they had the Windows line endings. That confuses Linux, and it went boom. But I have fixed it. So please try doing a git pull. It should pull in the updates, and then you should be able to build the image successfully. So please try that now if you are having problems. If you are not having problems, I appreciate your patience. So for those of you who are having trouble, please run it and give me a thumbs up if you're good, or like throw me the finger if it's not. We have no pretense of being family friendly here. But if it is working, you should see something like this. Yeah. Yes. What's up? What you got?
For example, if I want to change it to have a lot,
Yeah, that should work fine.
push it.
You don't need to push it. You just need to rebuild the image.
Put
So the Docker builds, all that stuff. So we do the Docker build command again. Docker build dot dash t intro server. You can probably type that.
Oh.
Yeah, there you go. So do that. It's rebuilding, and then do the Docker run again. And then intro server, or sorry, the dash p whatever.
Dash P.
8000 colon 8000. Yeah. Oh, that one.
And this way.
Hit the browser, refresh, you should be good.
Oh.
Good job, dude. So Vlad had an interesting little experiment. He tried changing the server script to say hello Vlad instead of hello world, and then he rebuilt the image because the file needs to be copied back into the image, and then he ran the container again. That is a good test if you want to experiment with stuff. Feel free to do that. Thank you, Vlad. That was cool. All right, those of you that were having trouble, are you okay? Good. Tom, too?
Yeah, I just switched to WSL.
Okay, cool. That works. Yeah, all right. So we're going to move forward then. So, if you got stuff working, congratulations. You built your first image and ran your first container from that image. So good job, everyone. A little drained from problem solving and not having slept sufficiently last night, but here we go. Okay, so we did all that. So cool. You created an image. You ran a container. That's all great. But now, what if you want to run many containers? Usually, these days, at least in the web ecosystem, you don't just have a single server running everything. You may separate your front end from your back end. You may have a back end API server and then a front end that just queries the back end for data. The old way was that you would have it all in one server, and there are still cases where you do that. It's called server-side rendering. You have a question? Or no? Okay. And server-side rendering is still a thing, but it depends on what you're doing. Alternatively, you may have microservices. So maybe you'll have your main application, and then you have like an auth service, or you may have like an image service, or whatever other services that talk to each other. So it's rare that you run a single application alone. Instead, what you can do is create multiple containers, and then run those containers in coordination with each other, and have them talk to each other to fill a full, complete application. That is a very common use case. And for local development, there's a tool called Docker Compose, which is wonderful for local development. The reason I make a stress point on that, or the reason I'm stressing that, I'm emphasizing that, is because there's an extension of, well, I call it an extension of, Docker Compose called Docker Swarm, which is like Docker Compose, but meant to be used across multiple computers, so you can distribute your containers. Docker Swarm sucks. Even on the Docker Swarm page, they say, go use Kubernetes instead. Don't use Docker Swarm. But if you're doing local development and you want to do local testing and all this kind of stuff, Docker Compose is excellent. It is wonderful. And Docker Compose allows you to say, hey, I'm going to define this service. This service should run a container based on this image. It should have these environment variables, these ports, maybe mount some files into it, whatever. And in this way, you can run a whole bunch of containers as kind of groups of services together, and you can just test everything locally. So let's say that you're a front-end engineer. Let's say you build web pages, right? But your system talks to the back-end to get data. I mean, maybe your team could set up a shared back-end development environment that everyone can access, but then you're all sharing data, right? And maybe if you're doing some sensitive testing, you don't want to share data with the other people. You want your own isolated environment. Wait, how do we get isolated environments again? Docker. So you could, if your backend team packaged their backend server into a Docker image, you can pull that image. You can run the server locally in a container. You could run the database locally in a container. If there are other services, you can run them locally in a container. You can set them all up with Docker Compose, because you guys can't see my screen. And then you just do one command, and you have the entire stack set up. And then you can just point your front end to your local backend, and you have a full, isolated, complete environment. So that's kind of the main use case for it. Or if you're a backend engineer and you don't want to use a shared database, you could just set up a database with with Docker Compose as well. But in any case, Docker Compose is great. We're going to use it right now. So how does Docker Compose work? First off, YAML. If you're not familiar with YAML, hopefully you're familiar with JSON. If you're not familiar with JSON, that's going to be hard for me to explain. Is anyone not familiar with JSON? Is anyone not familiar with YAML? Okay, one not familiar with YAML. So JSON, let's pull up. So JSON looks like this, right? Wow, that is huge, or tiny rather. So JSON looks like this. Give me a second to fix this, it's bothering me. Okay, where's my mouse? Okay, JSON looks like this, right? So you have something that defines an object. You have keys, and then you have values, right? Or keys and values, right? That's all good. What is with this indentation? Who wrote this? Ugh. Anyway, JSON, right? YAML is very much like JSON, but less square brackets and less quotes. JSON, or YAML, is like JSON without all the extra symbols and if you formatted it properly. Okay? So instead of having colon curly bracket to denote that we're going one layer in, we're doing an object kind of thing, instead it's just white space. So for example, there's this services key, and the value is this object, which has a server key and a client key. The reason I know that server and client are keys directly under services is because they have the same level of indentation. If you know Python, this should be familiar. If you're more of a C person, I'm sorry. but each level of indentation indicates another level of nesting, like nested objects. If you see a dash like this, that means that it's a member of an array. So in this case, ports contains an array, and in this case, this item in the array is a string. You can have an array of strings, numbers, objects. You can even mix stuff, although usually you don't want to because it's just more sensible not to. Strings don't necessarily need quotes around them. And that's pretty much it. Does that make sense for YAML things? Good? Good? Cool. So Docker Compose uses YAML. Although theoretically it should work with JSON, because JSON is technically a subset of YAML, but So first, it defines many containers, it handles network configuration for you, and it allows you to define ports and volumes. Wait, Beege, you told us ports, but what the hell's a volume? A volume is basically words. A volume is words. A volume is kind of basically a folder on some other file system, right? So maybe you have some files on your local computer that you want to appear in the container, and they're not in the image for some reason. Maybe they don't belong in the image because they're data files that shouldn't be passed around with the image. Or maybe you have some folder that you want to share among many containers, and so you can create a volume for that, and you can attach it to multiple containers. Volume is just kind of a separate storage that you can attach to a container to allow the container to access those files. Okay, that's a volume. Obviously, it's more complicated than that, but for purposes of usage understanding, that should be sufficient. But we're not going to do volumes today. So here we have a Docker Compose file that sets up two services, a server and a client. The server is the same server we built earlier, like literally the same server. The client is another script, which I'll show you in a second, which just sends HTTP requests to that server and prints the response. And it runs every 2 seconds. Okay? So this is just a quick little demonstration of linking or running multiple containers with Docker Compose, linking them, and I'm going to show you how this stuff works. So let's go back to here, clean up all this junk, get rid of this. So you know the server, we looked at this earlier. You know the, oh geez, I don't like, you know what, go away. Okay. You know the HTTP response, we did that already, right? In the client, we have another Dockerfile. Again, we're using Alpine. This time we're installing a tool called curl. Curl is for basically making web requests via command line. We're adding this client.sh file, and we're using some build arguments to tell it what address the server is at, so it knows where to request data from, and then what port the server is running at. Okay, so we include those at build time. All right, and then the script itself, again, we do trap stuff so that we can interrupt it properly, and then curl just queries that URL and port, and then it waits for 2 seconds, and then does it again. Okay, does that make sense? So the client, when the image is built, it is built knowing about the server. Honestly, that's not actually a good way to do it. It should just be environment variables, but I'm trying to keep stuff easy. And then it just queries the server every couple seconds. So cool, right? Hello? Hello? That's cool. Okay, goodbye. Cool. So you want to go back to the root directory, just the blog Docker directory, not the server directory. And if you do docker-compose space up, that will basically run this Docker Compose file. In this case, it will build this server image. It'll expose it on these ports, and then it'll run a container with these ports exposed, and it'll do the same for the client, saying that, hey, the client needs to talk to the server, so make networky stuff happen to allow that to work. All right, so now, if we do this, it builds both of the servers. Bro. Oh. Let's try that again. Whoa. Windows. Okay. So, let's try that again. It already built the client and server images, and now you can see it's showing logging output from both of them. The server is running, the client makes a request, the server sends a response, and there you go. Does that make sense? Cool. Is it? Can you guys run that on your system? Again, it's just docker-compose space up. Let's make this a little bit bigger. Whoa, it makes the whole thing bigger. That's not what I want. Okay. So try it yourselves. Let me know if it works. And then let me know if you have questions. Good? All right. And then I have another project to demonstrate if you want to see a more useful example of this. Are you guys able to get this running? Everyone cool? All right, it looks like they're able to sort it out on their own, so I'm just gonna go ahead and keep going. So let's real quick, let me just demonstrate another project just to kind of show how you would use this in the real world. Where is it? There we go. Yeah, buddy. Much better. Much better. Okay. Oh, that's cool. They made an icon for contributing. Look at that. So this is another project. This is CodeSoul. We're working on this event and member management system to help us coordinate events, because posting on Meetup, Facebook, LinkedIn is a giant pain, and I hate it. So I'd rather build a system to do it for me, where I can just enter the info once and it posts on all the stuff for me, and I don't have to deal with all the different social media, because I hate social media. But otherwise, I can't let you guys know about this stuff. So, this project is an ongoing project, by the way. If you're looking for a project to work on, let me know. Yeah, go ahead. Why not? Go for it. And so this is an example Docker image where we base it on a Java development kit image. We expose port 8080. We set some database variables. We set up the application directory, and then we copy our built Java server in there, and then we run the Java server. Okay, pretty typical, very similar to the one we did as part of our tutorial here. Bro. Yeah, okay. And then we have a Docker Compose that runs a Postgres database. Okay, so the database system for us to store data and all that fancy stuff. We have a whole bunch of configuration, including a volume, because we want our database's data to persist when we bring up the system, bring down the system, because we may use the same data between tests. We also set up a user interface for the database if you want to inspect it instead of doing crazy SQL stuff, or instead of doing SQL over command line. And then we can run the server locally. So I just want to demonstrate real quick how this kind of works. So if I do a Docker Compose up, let's do it. Crap, which port is this running on? So this is adminer is a utility that acts as a admin interface for databases. And I have it configured to point to the default server of my database service here. So it's running on port 8000. So I'm going to do this. Going to go to localhost port 8000. And here is that little adminer database interface. And I can not remember what the password and all that is. Manager. And then here we go. Bro. Oh, it's Postgres. Thank you. And there we go. Now I'm in the database. Woo! And I can do database stuff, right? So this is just an example of, if you're a back-end engineer, how you could set up an environment to run the database, to have a UI interface so that you can test the database and check that your back-end is doing the proper databasey things. So that was just something cool I wanted to demonstrate. But it's a very common workflow. You'll see engineers use this all the time, and it is super convenient once you figure it out. Figuring it out the first time is a bit of a challenge, and that's why DevOps is a thing. But once you do get it set up, the developer experience is kind of nice. So, well done, everyone. Today we covered what is the problem that Docker tries to solve. What exactly is Docker? Within Docker, what are containers and images? We ran our first container. We built our first image and ran a container from that. And then we ran a bunch of containers using Docker Compose. I do recommend playing with this stuff, much like Vlad did. Try editing some things and see how they work. Try experimenting and breaking things. It's okay. It's all software. You can always just do a git reset to get the original version again. And if you have trouble or questions, you can contact us on Discord. Anyone have any final questions before we end today? Damn. All right. Cool. So there's a whole bunch of additional resources here if you want to read up more. I include links to the references for Dockerfiles if you want to see what all those different commands are, because from add, run, expose, and command are not the only ones. There's a whole bunch more. I also linked a reference to Docker Compose so you can see all the more complex things, along with some other references for learning Docker, and even like a full curriculum on how to learn Docker if you want to go deeper. So thank you very much as usual. Again, we're Code Soul, we do IT stuff. And if folks still want to hang out and have time, we're going to go get some chicken. So thank you for coming. And if you have any questions, let me know. And thank you very much for your time. All right, bye-bye, Internet.